Okay, for question number 5, a piston cylinder device contains 0.15 kilogram. So initially at 2 megapascal. So it's state number 1. Okay, you are given mass, you are given P1 and T1. The air first expand as isothermally expand, expansion to P2 500 kilopascal, then compress polytropically. So you have compress. So you have another state. So this is state number 2. The air first expand isothermally to 500 kilopascal. This is isothermal. Then compress polytropically. So this is polytropic with a polytropic exponent n equals to n equals to 1.2 to initial pressure. So this is number 3. Okay, n equals to 1.2 to initial pressure. What is your initial pressure? Initial is the number 1. Okay, so your P3 in here is actually equals to P1. Okay, and finally compressed at the constant pressure to initial state. Yeah, at constant pressure to initial state. Okay, oh sorry, this one initial pressure 1.2, n equals to 1.2. Yeah, okay. So the question is, determine the boundary work for each process. Boundary work, it means work of boundary, but you have 1 to 2, 2 to 3, 3 to 1. Okay, so actually this is P constant, this is compression. Okay, so your work of boundary is actually equals to work of boundary 1 to 2 plus work of boundary 2 to 3 plus work of boundary 3 to 1. Okay, so you need to find each of it. So the first process, work of boundary expansion, isothermal. So what is the equation for isothermal? Okay, P1 V1 ln V2 over V1. So find the value for each of this. Okay, so plus work of boundary 2 to 3. 2 to 3. So this is polytropic. Polytropic with n equals to 1.2. So the easiest one is P3 V3 minus P2 V2 over 1 minus n. Okay, and finally you have compression at P constant. P constant 3 to 1, so you can use PDV P3 V1 minus V3. Oh sorry, V1 minus V3. But the question is how to get this value. Okay, so how to get this value? You can get it from table. Okay, so V1. So this is air. So you always use PV equals to MRT. That's the clue. So how to get V1? Insert the value. Okay, same goes for V2. Insert the value. Okay, but for the polytropic, you can use equation of P2 V2 power of n equals to P3 V3 power of n. Okay, so that's the clue how to solve your problem. When you have all the values, you can insert into the equation and you're done. You will done. Okay, calculate network of the cycle. So network equals to determine the boundary for each of the process. So you need to find one by one. Okay, so this is for the net. This is actually for question number 2. Okay. Okay, question number 6. This one is using closed system. Okay, so I'm going to KIV this one. Okay, question number 7. Everything is about, you can get it from the note, so I'm not going to do this. Question number 8. Okay, a piston cylinder device initially contains nitrogen. So this is nitrogen. So everything is about PV equals to MRT. Okay. Okay. What do you have is you have M. Okay, M, you have P1, you have T1, you have V1. Okay. The volume of the nitrogen inside is initially 3 meter cube. Now the nitrogen is compressed slowly. Yeah, compressed. Okay, under polytropic. Okay, with PV 1.2 equals to C. Okay, until the volume is reduced by 1/3 from its initial volume. So V2 equals to reduced by 1/3. So what's left is 2/3 reduced by 1/3. So 3/3 minus 1/3. So you will get 2/3 V1. Okay. So using this equation, and this is polytropic, so you can use this. P1 V1 power of 1.2 equals to P2 V2 power of 1.2. So, okay, with that relationship, okay, you can determine the final temperature of nitrogen. Yeah, okay, if you can get P2, then you can get T2. Yeah. Okay. So next question is calculate the amount of work. Work of boundary is equals to polytropic equation P2 V2 minus P1 V1 1 minus N. Okay. So settle with second one. Question number 9. This is helium gas. So still using PV equals to MRT. Okay. You have P1, you have T1, you have V1. The gas is then compressed. So it's quite similar with question number 8. This is polytropic. Okay, you have P2, you have T2. Okay, determine the work done. The work done. How to find the work? Okay, work. This is polytropic. So work of boundary equals to P2 V2 minus P1 V1. 1 minus N. The problem is how to find V1 V2. Okay. Okay. So you are not given the mass. So using this one, maybe you can find the mass first. Okay. From the mass, you are having the same mass 1 and 2. State 1 and state 2, you are having the same mass. So maybe you can, using the same mass, you can get V2. Okay. Okay. Then, this is polytropic. You don't have N. So another equation that you can use is P1 V1 power of N equals to P2 V2 power of N. Insert all the values, you can get N. Okay. Remember, N is not just divide this by this, yeah. This is about ln. Be careful, this is mathematics. Okay. When you found the N, insert the value of N, V2, V1, you will get the answer. Okay. Then you want to find the heat transfer during this process. So this is actually energy. So this is closed system. Okay, this one is for the next module. Okay, that's all.